I'm asking you to figure out what changes to the smacof algorithm settings will make it better at creating a low-dimensional representation of your data that accurately reflects the original distances between data points. We're looking for options that improve the algorithm's optimization process. Think about how tweaking the settings can affect the accuracy of the results. Increasing "n_init" means you'll run the algorithm multiple times with different starting points. Imagine it like trying different paths to get to the bottom of a valley. The algorithm is looking for the best representation of your data, and starting at several different points increases the chances you'll find the lowest point, which translates to the most accurate representation. Oh, this is definitely not a good idea. Decreasing "max_iter" cuts short the optimization process, so the algorithm may not find a good solution. It's like stopping before you reach the bottom of the valley. You'll end up somewhere higher, which means less accurate results. This parameter determines the dimensions of your final representation. Increasing it gives the algorithm more flexibility to represent the data. It's like giving yourself more tools to describe something complex, however. Be careful. Too many dimensions might lead to overfitting, learning the training data too well but performing poorly on new data, which isn't necessarily better. "random_state" is like setting the seed for a random number generator. Changing it only alters the initial starting point of the algorithm. It doesn't inherently improve accuracy, it only changes where the algorithm starts looking for the best representation. It's like starting your valley search from a different place, there's no guarantee of getting a better result. I see that increasing "n_init" improves accuracy. "n_init" controls how many times the algorithm restarts with different random starting points. More restarts mean a better chance of finding a good solution, because the algorithm might get stuck in a poor local minimum otherwise. Think of it like searching for the lowest point in a valley. Multiple starting points increase the likelihood of finding the actual lowest point instead of a slightly lower point nearby. Decreasing "max_iter" is harmful. "max_iter" sets the maximum number of iterations the algorithm runs. Fewer iterations mean the algorithm might not reach a good solution because it hasn't had enough time to fully converge. It's like baking a cake. If you stop baking too early, you'll end up with a half-baked mess. Changing "random_state" has no effect on the solution's accuracy. "random_state" is just a seed for the random number generator. Changing it just shuffles the initial conditions. It doesn't make the algorithm magically better. Imagine it like choosing a different starting point on the same terrain. The best location in the valley still remains the same. Increasing "n_components" can help, but only up to a point. "n_components" sets the output dimension. Increasing it lets the algorithm capture more complex relationships in your data. However, too many components might lead to overfitting, which means the algorithm captures noise instead of the actual signal. We are trying to improve the accuracy of a dimensionality reduction technique called smacof, scaling by majorizing a compromise. It's a method used to represent data in a lower dimension while retaining as much information as possible. This question asks you to identify which changes to the smacof, scaling by majorizing a compromise, algorithm's parameters will make the low-dimensional representation of the data more accurate to the original distances. We'll look at how each parameter affects the result. Let's dive in. "n_init" parameter controls how many times the algorithm restarts with different random starting points. Increasing this value means we'll run the optimization more times, each time potentially finding a better solution, improving the accuracy. Imagine it like searching for the lowest point in a valley. More attempts means you are more likely to find the true bottom. Think of it like this. More tries, better chances of success. The "max_iter" parameter sets the maximum number of iterations. Decreasing it means we stop the algorithm before it converges to a good solution. This is like baking a cake and pulling it out of the oven too early. It won't be fully cooked or as good as it could be. We should always allow the algorithm enough time to find the best solution. The "n_components" parameter determines the dimensionality of the output. Increasing this could potentially improve accuracy by giving the algorithm more dimensions to work with, allowing for a better fit to the data. However, it is important to note that increasing this too much could also lead to overfitting. It's a balancing act. The _random_state parameter sets a seed for the random number generator which controls the algorithm's starting point. While changing this seed changes the results of the algorithm each time, that doesn't make those results inherently more accurate. It just means you get a different result due to a different starting point in the calculation. Changing the random seed doesn't directly influence the solution's quality. I see _components as the target dimension for the data. Think of it like deciding how many dimensions you want to draw your points on. A flat piece of paper, 2D, or a room, 3D, or more abstract spaces, 4D and beyond. Increasing this value gives you more space to separate the points, potentially leading to a better representation of your original dissimilarities. But be careful, because if you have too many dimensions, it is like trying to cram many different patterns into a small space, increasing the risk of overfitting. Too many dimensions could lead to a very specific solution that fits your current data really well but doesn't generalize well to new data. I interpret n_init as the number of times we try to solve the problem from a different starting point. Imagine you're searching for the lowest point in a valley. With more starting positions, the higher the chances of finding the true lowest point, not just a relatively low one. A higher n_init increases the computational cost, but the chances of finding a better embedding increase as well. It's like trying different routes when navigating to find the best possible path. I think of max_iter as the number of steps we allow the algorithm to take in its search for a good solution. Think of it as the number of times a hill climber can try to reach the lowest point. Too few iterations will result in a quick, but potentially poor answer. The algorithm hasn't had enough time to fine-tune its result. You need enough iterations for the algorithm to converge and find a well-fitting embedding. I see _random_state as the seed for the algorithm's random number generator. It's like choosing a starting point in a random way. Changing the seed gives a different result each time but does not guarantee a better one. It just changes the random path taken, not the quality of the final solution. A fixed number can allow you to reproduce results if you run the same algorithm multiple times. I'm using scikit-learn's smacof, scaling by majorizing a compromise algorithm. It's a fancy way to squish high-dimensional data into fewer dimensions, like going from a 3D model to a flat 2D picture. The goal is to keep the important relationships between the data points intact. My 2D picture isn't quite right. The distances between the points in my picture don't match the original distances very well. I need to improve the accuracy of my 2D representation. I want to make my 2D representation of the data much more accurate. I want the distances in my picture to better reflect the original distances. One thing I could try is to increase the n_components parameter. This parameter determines how many dimensions I'm using for my picture, e.g., 2D, 3D, etc. Increasing it might give me more space to spread out my points and represent the data more accurately. However, be cautious, because going overboard can lead to overfitting. I could also try increasing n_init. This tells the algorithm how many times to start from a random arrangement of the points and try to improve it. More attempts increase the likelihood of finding a better representation of the original data. Think of it as trying different starting positions in a maze. With more tries you have a better chance of finding the best path. Decreasing max_iter, the maximum number of attempts the algorithm makes to improve the arrangement, would be a bad idea. It's like stopping before finding the best path through the maze. I need it to run longer to potentially find the optimal solution. Finally, _random_state simply controls the starting point randomly. Increasing it just changes the random starting position. It doesn't guarantee a better solution. It's like choosing a different random starting point in the maze. It doesn't ensure a better outcome. The result from my algorithm is not very good. The algorithm did not generate an accurate low-dimensional embedding for my data. I start with a dissimilarity matrix which shows how far apart each of my 10 data points are from one another. I want to represent my 10 points in a lower dimension, like a simple 2D plot. while maintaining the relative distances as much as possible. Let's improve the accuracy of my smacof algorithm. I'm using the smacof scaling by majorizing a compromise algorithm, a method used for dimensionality reduction. It takes a dissimilarity matrix as input, a table showing the distances between data points, and outputs a low-dimensional representation, like a 2D scatter plot, that tries to preserve those distances as much as possible. It's an iterative process. It refines the low-dimensional representation until it's a good fit to the original data, or until it reaches a preset limit. Pretty cool, huh? This is the starting point for smacof. It's a square matrix that shows the pairwise dissimilarities between your data points. Think of it like a map of distances, where each cell tells you how far apart two specific locations are. smacof uses this information to create its low-dimensional embedding. It's the foundation of the entire process. This is what smacof produces, a lower dimensional representation of your data. For example, if you input distances between 10 data points, smacof could return coordinates for each of these points in a 2D space. The goal is for the relative distances in this low-dimensional space to closely match the original dissimilarities. If the output doesn't match the input, then we need to improve the process, hence the original question. This is where you'll visually see the result of smacoF's work. This is the core question. The problem is that the low-dimensional embedding produced by smacof doesn't accurately reflect the original data's dissimilarities. So, I'm figuring out which parameter adjustments will help improve the algorithm's output, making the low-dimensional representation a more faithful picture of the original distances. Let's find the best settings. The _n_components parameter controls the dimensionality of the embedding. Increasing it means creating a higher dimensional embedding, e.g., from 2D to 3D. More dimensions can sometimes capture more complex relationships within the data. However, there's a trade-off. Too many dimensions might lead to overfitting and make the result less generalizable. It's a balancing act between detail and simplicity. The _n_init parameter sets how many times smacof runs with different random starting points. Think of it as trying different approaches. By increasing this number, I increase the chances of finding a better solution, a lower dimensional representation that fits the original dissimilarities better. More tries often mean better results. The _max_iter parameter sets the maximum number of iterations, optimization steps, smacof runs before stopping. Decreasing it means prematurely halting the algorithm before it fully converges to a good solution. This is likely to produce a worse embedding. Let's not rush the optimization. The _random_state parameter controls the randomness in the algorithm's initialization. Changing this number changes the starting point for the optimization. It doesn't directly improve the accuracy. It just produces a different result based on a different random starting position. It's about reproducibility, not accuracy improvement.